Okay, question number 13. Got this riverbed. It looks symmetrical. I'm not sure whether it'll be symmetrical until later on. Given the algebra for that curve. So I think I'm just going to find, for Roman numeral part 1, x-intercepts by making y equals 0. Hopefully that will mean it's symmetrical, in which case I can just take the depth of the river as its deepest as the y-intercept. If not, I might have to use calculus to find that minimum point as a flat point. Area is what integration is for if year 8 formulas don't do the job, so that'll be my strategy for Roman numeral part 3. And Roman numeral part 4 is just worth 1 mark, so that'll probably be super simple. I'm going to use the smaller and simple strategy for that, and then I'll have a look at Roman numeral part 5 later on. So, question number 13, here we go. Roman numeral part 1. Finding the x-intercepts by making y equals 0. Times by 16 divided by 3. So therefore it is symmetrical. Let's not forget to answer the question. Length AB equals 8 meters. I was interested in being symmetrical, therefore I can just make out do a y-intercept. So it's put 0 in there, you get -3, so 3 meter max depth. Area of the cross section. So the area goes as far to the left as 4, as far to the right as -4, but because it's symmetrical I'm going to just do a little doubling trick here. So this is the area I want. Do a bit of mathematics here, bring that over. 6 over 16 is 3 over 8. So out of that pops -16, so the area is 16 square meters. Roman numeral part 4 I said would be quick. Smaller and simple strategy. If you had an area here of say 5 and through this comes 20 meters every minute, the volume will be just times this. So for us it's 20 times 16. It's Roman numeral part 4. So the volume will be 16 times 20, which is 320 cubic meters. Roman numeral part 5. Why might this model not be a good model to work out how much water is passing through. Well, just tracing back through all my logic, I made a lot of the fact that the riverbed was symmetrical. That's probably unrealistic. It's highly unlikely that it'll be a nice smooth curve though in some things in nature you do get very smooth shapes. And finally, because of the resistance of the bottom of the river, I mean, I don't know much about the resistance, but it seems to me that the flow won't be the same throughout the cross section. Pretty sure I've seen stuff on the TV about how the middle part of the river is the best part to row in, or travels the slowest, or maybe that's a big myth. But in any case, I'm fairly safe to say, for the purposes of getting one mark, that we don't have good enough reason to say that the rate of flow will be uniform across the cross section.